Hello, everybody. We're the data crew, and we are looking at IBM HR data for our presentation. So just a quick overview. Attrition, our variable of interest is attrition, and attrition is a problem that impacts all businesses, irrespective of geography, industry, or size of the company. Employee attrition leads to significant costs for a business, including the cost of business disruption, hiring new staff, and training new staff. As such, there's a great interest in understanding how the drivers of and the minimization of staff attrition. The goal here is to analyze the predictive modeling capabilities and see if we can understand various factors affecting employee attrition on this IBM dataset using different analytic techniques. So real quick, we had 35 variables. We identified 8 categoricals, 8 ordinals, and the rest were all numeric. We had to take out several employee count, employee number over 18 standard hours because they weren't like real variables. They didn't provide any additional information. We created dummy variables for categoricals. We also converted some to ordinals to numeric ordinals. And we performed a log transformation on monthly income because it wasn't a good distribution. And lastly, we checked to see if there was any missing data. And thankfully, we did not have any missing data in this data set. So the first problem we encountered here was with these visualizations. And as you see up the top, we have a class imbalance. We have far more no's to attrition than yeses. So we had to figure out how to deal with that problem. And we decided to oversample, which created some more a better distribution between the two. We also did some quick distributions to see how things like business travel, marital status, and work-life balance and overtime affected attrition or were related to it, along with the income. Like, as you can see, less income means higher attrition. So anyway, our first lines of analysis, first one is going to be principal factor analysis. We're going to have multiple correspondence analysis, several regression techniques with categorical response, and we're going to have linear discriminant analysis at the end. So to start, we looked at principal factor analysis, and we wanted to see some factors out of that. We wanted to see how these factors were built and how the variables are interacting with each other. So as I mentioned before, we converted some of the categoricals into numeric. I got rid of the ones that didn't work. We performed a core test to see which variables had no relations. We had several that I had to take out: distance from home, gender, job involvement, monthly rate, total work-life balance, and business travel. They all had to be taken out. We got our correspondence plot. We can see some groupings here already forming, but it wasn't super clear. So we wanted to move on to principal component analysis to get an idea of how many categoricals, how many factors we're going to need. You can see V1 equals 1 suggested about 7. The knee might suggest 4 or 5 here. Either way, not super clear yet. So we decided to run a parallel analysis on it. This said we should have 6 factors and 5 components. So using this, I decided to test 5, 6, and 7 to see which ones would be best. To start, you can see 5 and 6 were not nearly enough. They didn't capture enough variance, and they did not break up the variables into particularly good factors. And it also, as you can see down here, left out a lot of the variables themselves. So 5 was bad, 6 was better, but still not great. Moving on to 7, we actually got a better outcome. It included all the variables and it broke them up into nice chunks. And we can also see we captured more variance. We captured about 1.61, so about 61% of the variance, which is just over that 60% threshold we needed. So you can see these were broken up into pretty good categories. The first one would be, time of the company, seniority would be second. Third could be performance, marriage, and stock options. So these broke up into fairly logical categories, and we can sort of see how these factors are interacting. And we would go on to use this with our regression analysis later on.
This is Eric from Data Crew. Our second line of analysis was multiple correspondent analysis. MCA focused on capturing the association and dependencies between categorical values. And also, MCA provides coordinates, contributions, and cosine values. All these values can be used for further detailed analysis. And these are some of the libraries. There are many libraries for MCA. And we use Factor Minor R library for our analysis. And I also provide a link that has additional information, including implementation of MCA. In MCA, on Factor Minor library, there are 2 method parameters. One is BERT, which is used when you have multiple categorical variables. And the second one, indicator method, is a default method, is for categorical, a binary categorical variable. And everyone's familiar with this mosaic plot. On the left-hand side, we have this mosaic plot, and sales representative, and being single, has the highest correspondence. And on the right-hand side, you can see there's high correspondence between sales representative and attrition. Also, there's correspondence between a laboratory technician and attrition as well. And we have a couple of these multiple correspondence plot that is going to explain how you could analyze it, you could interpret it. And up here these are the variables: attrition, job role, and marital status. And these are the same ones we used on a prior slide on this mosaic plot. Okay, first, you pick a categorical value. Now we chose attrition, being yes, and from the center you draw a line to that point, and then you draw a line with a categorical value that you want to make a comparison. So we chose job roles, and we draw a line. And when the angle is the closest, higher the correspondence, or meaning it's smaller the angle, more it corresponds with this categorical value. Like on this one, sales representative has the highest correspondence to attrition. Now on the second slide, this is closer to proximity, reflects similarity between categorical value. For example, this group and this group. And these set of groups reflect similarity to attrition, opposed to these groups on the opposite end, which shows dissimilarity with attrition, with attrition of being yes. And just to conclude, MCA is dimensional, just like PCA, and MCA is for reduced dimensionality for categorical variables. And from the analysis, from the MCA analysis, there's some of the variables: travel frequently, single, overtime, and sales are some of the features that share similarities with attrition.
Hi, my name is Jitin, and I'm part of the data crew. And my third line of analysis is regression. To perform the technique, for regression analysis, since our response variable was categorical as attrition, we went ahead with logistic, reg subset, ridge, lasso, and elastic net to check the performance of the models. In order to do that, we wanted to capture every variable that was there in our data, and so we performed the PC and PF again, having everything in the data set. So we converted them to converted the categorical data as factors and created dummies. As I mentioned earlier, monthly income was transformed to log, and we went ahead with the PCA for that. So for the PCA for regression, as you can see, the knee plot and the parallel analysis suggested us for 18 factors, but we took ahead with 13 factors to go ahead with the just about minimum requirement of the variance captured. And we from the PFA regression principal factor analysis from the 13 factors, we kind of inferred all these factors having like RC1 total experience, HR profile, sales and marketing, marriage stock performance manager profile, education of a manager, etc. From this slide, you can see, total variance captured is 58%, and it kind of, the factors are grouped together pretty decent. We went ahead with, for our regression technique, we divided the data into 70% and 30%, training and testing, and perform the logistic regression where we see the AIC is 2102.6, having a goodness of fit at a significant level. This is the model equation which we inferred out. This is the performance of the logistic regression, where we can see the sensitivity is 69% for logistic training and the 73% for testing. We concentrated more on the testing sensitivity because we wanted to capture more of the true positive, because of which we put the threshold of 0.5 as we had the balanced data as of now. Then we went ahead and did the reg subset regression. As you can see from this plot, we removed the non-significant variables. This is an adjusted R-squared plot. All the variables are significant at this level with the AIC value pretty decent. This is the BIC scale technique that we analyzed, removing all the non-significant variables. We are left with this many number of variables with everything significant with the AIC as 2113.3. This is the comparison of the goodness of fit for the adjusted R-square and the BIC, which are pretty decent. And this is the model equation that we had. Couple of them having a positive correlation, like coefficient, and couple of them having negative coefficients. The reg subset performance, if you look at this, we had the adjusted R-square for the training, for the and the testing, for similarly BIC for training and testing, and we'll see the adjusted R-square with the testing came out pretty good, a little bit better than the other ones. Similarly, we went ahead with the ridge subset here to specify that we went ahead with lambda min because we wanted to capture more of the confidence interval so that we capture more of the true positives. And as mentioned earlier, we had the threshold as 0.5. This is the model equation. The performance of the ridge regression, we had again the ridge on the test with 73%. No significant difference of, to indicate high overfitting. So we are good at this place. Similarly, for the lasso regression, we performed the similar activities with the lambda parameters with having the maximum confidence interval with lambda min. And this is the model equation for the lasso regression. The performance for lasso was again like lasso, and the test was 74% with accuracy of 70%. Elastic net, for elastic net, we went out with a for loop. We're having a range of alpha from 0 to 1 with an increment of 0.1 to capture and confirm capture the performance. The model reported us at alpha 0.55 and gave a performance which is almost, which is exactly similar with lasso test with accuracy and sensitivity and other parameters. So this is the final model comparison of everything, where we see slightly difference of between all the models, but since we want to capture more of the true positive, we are looking at more every bit of the percentage. So looking at this, we have the lasso and the elastic net reporting the same thing with the F1 score as 70%. So we kind of see that lasso test is our like good model there. And if you interpret the model equation, we see some parameters which has high coefficient with RC8. So we have RC3. So if you look at the factors, RC8, which is a factor of overtime and research scientists, RC3, which is a factor of sales and marketing people, RC2, which is a factor of HR profile, are affecting like positive effect on the attrition rate, while RC6, which is like having a negative effect, which are the manager profile that don't not to quit the company much. So this is kind of, coinciding with our initial line of hypothesis. So I'll pass on that to Denver.
So the fourth line of aspect in our analysis was a linear discriminant analysis. So a LDA can help HR professionals in recognizing employees who are at high risk of leaving the company, allowing them to take proactive steps to retain valuable talent. So after doing LDA and considering all the variables, so here we get a plot of LDA model, which displays the separation of the groups. Although the discrimination is not highly pronounced, this is possibly due to the presence of bias and noise, which was introduced during the oversampling process. So after this, we see the performance metrics of LDA. So we can see the sensitivity for training is 84% and for testing is about 88%. And accuracy is around 79% with an overall F score for training about 81, and for testing about 83. So the F1 score is an harmonic score, and the threshold value was set at 0.5 to measure the performance. So apart from this, we analyze the LD1 values from the model. So here we can see the LD1 values for age shows that a decrease in age is linked to a higher likelihood of being associated with the discriminant function related to attrition, suggesting that younger employees are more prone to attrition. And for the business travel, the travel frequently, we can see that it has a positive coefficient, which indicates that employees who travel frequently are more likely to be associated with the discriminant function for iteration. Similarly, we can see it also has overtime also has a positive coefficient, so which suggests that employees who work overtime are more likely to be associated with the discriminant function for iteration. So to conclude our analysis, according to MCA analysis, it was observed that individuals who travel frequently, work overtime, are in sales department, have lower job levels, and are single, are more likely to experience a higher frequency of iteration. And according to the regression analysis, employees who engage in overtime, work in the sales and marketing departments, have HR profiles, and are single, are more likely to have a higher frequency of iteration. And from the LDA analysis, it was found that individuals who work overtime, are in the sales department, are single, and travel frequently, and with a lower job roles like lab technicians, are likely to have a higher frequency of iteration. So summarizing, based on the observations, there is a consensus that individuals who work overtime, travel frequently, and have lower job levels, and are single, are more susceptible to iteration. Therefore, it is advisable for companies to take necessary measures to closely monitor and address these factors in order to control iteration effectively. Thank you.